With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The question given here is 27 degrees centigrade. N2O4 has vapor density that is 230 by 6. If the equilibrium pressure of the system is given to be 0.96 atmosphere, then we have to find out the value for delta G naught, and the value of log 2 is also given, that is 0.3 here. So let's solve the given question here. For solving this question, let's see, first of all we are given here with the N2O4, which is quite unstable in nature, and being unstable in nature, it gets converted itself into NO2. Okay, and by considering all the concentrations here at equilibrium, we can determine the value of equilibrium constant here. So it can be determined by this formula, that is Kp will be equal to 4 alpha square by 1 minus alpha square into pressure. Okay, so here the alpha is the degree of dissociation for the N2O4 and NO2 system. Okay, then we can calculate the value here by just calculating the value of alpha. Now how we can calculate the alpha? For this we will use another formula here that can be expressed as d by d is equal to 1 plus n minus 1 whole alpha. Okay, where d is the molecular, capital D is representing the molecular weight. Okay, that is the molecular weight, and small d is representing the density. Okay, so let's put the values here. N is the number of moles which are present in the equilibrium. Then we can put the values here. For capital D, we can calculate the value of molecular mass. The molecular mass of N2O4 comes out to be 94 here. Okay, so we can put it like this, that is the 94 divided by 2 here, then divided by 230 by 6, that is the density which is given in our question, then 1 plus whole 2 minus 1 whole alpha, because it is given that n is the number of moles is 2 here. Okay, so here by this expression we can calculate the value of alpha here. The alpha comes out to be 0.2 here. Okay, so this comes out the value of alpha, that is the degree of dissociation here. Now we can put the value of alpha in this expression, that is the expression first here for the equilibrium constant, okay, of the reaction. Then we can calculate the Kp value here. So let's put the value here. The Kp value can be calculated by this formula, that is 4. Alpha is given, that is 0.2. So 0.2 whole square divided by 1 minus 0.2 square into pressure which is given in our question, that is 0.96. Okay, now we can see here that this term on solving will give us value, that is 0.16. Okay, so that comes the Kp value of our question here. Okay, so that is giving us the Kp value. Now by knowing the Kp value, can we find out the delta G value? Yeah, definitely, because the formula which we will be using here will be delta G naught will be equal to minus RT ln Kp. Okay, so this is the formula you must remember for any future use also, how we can relate the standard Gibbs-free energy change with the equilibrium constant. Okay, so that is the minus RT ln Kp. Here ln can be converted into log by just multiplying the whole term with the 2.303, that is minus 2.303 RT log of Kp. Okay, now put the values here in this expression. As we know, R is the gas constant having the value that is 8.314. Then temperature is given in our question, and that we can put in Kelvin as the 300 Kelvin, as it is given to be 27 degrees centigrade. That is why we are converting it into Kelvin and writing it 300K. Okay, so let's put all the values here. That is minus 2.303 into 8.314 into 300, that is temperature. Then log Kp we have calculated, that is 0.16. Okay, so this will give us the delta G naught value. So let's calculate it, and this will give us value, that is 4.595, that is in negative sign. Okay, 4.595 kilojoule. Okay, so if you want to change it from the kilojoule to calorie, as in the question the options are given in the calorie only. You know what is the conversion unit? That is 1 calorie will be equal to 4.184 joule. Okay, 1 calorie is equal to 4.18 joule. So let's convert the given values. Here we had calculated delta G naught value. Okay, so this was the value for delta G naught. So for conversion, let's write the value delta G naught value in the calories. So divided 4.595 divided by 4.184, that will give us value, that is 1.1 kilocalorie. Okay, so this is our final answer, because the question was demanding us the value of delta G naught, which comes out to be 1.1 kilocalorie. Okay, so let's see in the options given above which one is showing us this value. So you can see here that the option A is giving us this value, then this is our correct answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.